Welcome to this lesson. So in this series of lesson, we want to look at enterprise application development with autonomous agents. Of course, everybody knows agent is what is training now, and it is important that you know what agents are, how to build them, and how to integrate them into enterprise system, or how to integrate them into any website or application. So we have a series of chapters here, and there's code repository which I have separated. So I'm just going to give definitions, and then we'll look at the practicals in a separate videos, to avoid spending too much time on a particular topic. So autonomous agent core is what this lesson is all about, and of course please follow along and subscribe, and you are going to enjoy the lesson. So we'll be looking at these chapters. Chapter 1 we have agent. 2 we'll look at design. 3 we'll look at UX for agent, that is designing UI interfaces for agentic system. Chapter 4 we'll look at tools. Chapter 5 orchestration. 6 memory. 7 learning. 8 we look at multi-agent. 9 validation. 10 monitoring. 11 loops. 12 security, and 13 collaboration. So from agent foundation to production, that is, so at the end of this lesson, what you should be able to do is that you should be able to build an agent and integrate it into a system. Alright, chapter 1, introduction to agents. So what are agents? What are these agents that we've been talking about? How are they different from the real LLM or generative AI that they were built from? So the foundation for building reliable autonomous AI applications. So we have input, agent, tools, and results. So as we have all been saying before, agents are just a kind of generative AI that can act on their own, reason on their own, and solve problems without any human interaction, or with little human interaction. They are autonomous, that is, they can act and think on their own, they can take decision on their own, and they can solve problem and arrive at a solution without a guide, based on how they are programmed. Okay, so what are autonomous agents again? So they are software that reasons, that decide, that adapts, reflects, acts across tools and systems. Of course, they are systems. They are not human being or robots. They are systems. So unlike a scripted bot, an agent can interpret ambiguity. They can choose a strategy. They can use tools and adapt when the environment changes. So ability of a system to adapt to changes is, that has to be before we say they are living things. So agents are just like living systems, that can do all these things on their own. So they are context aware, they understand context, they can reason and plan, which is under react. They can make decision based on selection, they can execute action, and they can give you outcome and feedback. So simple rule, if the system must decide the next best action, you are entering agent territory. So if you are building a system that must decide on the next best action, then you are no longer dealing with just an LLM, you are building an agent. That is an agentic system. So why agents are possible now? Why are they possible? Of course, in the around 2010, 2015 thereabout, all we have is data science, machine learning. Then around 2022 or 2020 thereabout, we started having this LLM, GPT-2 to GPT-3, and so on and so forth. Now we are in the era of GPT-5, Claude, Gemini, and what have you, which are performing well. So foundation model remove the biggest barrier to intelligent applications. So we have agents today because of all this foundation model, and we are moving toward what we call artificial general intelligence as well. So which is where all these are going to. So application experience charts, workflow UI, Copilot, back office portal, agent runtime, planner, memory, tool selection, and policy checks. So all this application, the experience we have before is just to, go to a chatbot, build a chatbot, you build a workflow, like Power Apps or step functions or logic app that can act as a workflow and implement system. But what we have now built on LLM is an agentic runtime that can plan, that can execute memory, both short time and long time. They can select two, which are functions used for solving problem, and they can, implement policy check. So foundation model language, reasoning code, vision, structured output. So foundation model enable this agent to reason, to code, to vision, and to give structured output. So enterprise tools plus data, API, database, document, SaaS platform. So agents can integrate with all enterprise tools. They can integrate with enterprise data. They can integrate with API data. They can integrate with databases. They can integrate with your documents on your drive, on your laptop, and even SaaS platform as well. So cloud platform, agent can also interact with compute. They can interact with your storage, identity, network, and monitoring. Agent can connect to every application on your behalf and perform an operation on your behalf based on how it is programmed. So capability shifts. One model can handle many tasks. No separate ML project for every use case. So you don't have to build machine learning for every use case. I want a predictive modeling, let me build predictive modeling. Oh, procurement, I want to, interact with vendor, let me build only an agent that can interact with vendor. No, you can combine all these systems into, an agentic system that will act autonomously and perform the action. So agent can also use tools natively. So models can call API, produce structured output. They can use tools. Tools are Python functions designed to solve problems. So long context is practical. Agent can reason even more document and conversation. So cost and complexity dropped. So we no longer have a complex situation where you rely only on consulting firm to solve your problem. So you can build an agent that will integrate into your system and solve this problem on your behalf. So why your team just sit and prototype and ship faster. Types of agent in practice. Most production use cases fit into a few practical categories. So we have many types of this agent. There are many types out there. So you can design agent based on business task, which is fixed workflows. Okay, workflows are not actually agents. Workflows are just like hybrid infrastructure, which can only do something when they are prompted. We have conversational agent, like a support and assistant, like customer support agent, virtual assistant agent. Those are conversational agents. We have research and analytic agent, search and synthesis, so which they use deep thinking to perform research. We have developer agent, which assists developer in coding and CI/CD workflow, which is DevOps. We have browser, voice, and video agent. These are multimodal agents that can take actions, generate voice, video, or browse web on your behalf. We have domain specific agents. So these are very, very plenty. Domain specific agents are enormous out there. Okay, I myself, I just use MAS to design up to like 10 million agent design pattern for like 20 industries, starting from oil and gas, climate, finance, medical, security, IT operation, development, farming, agriculture, and etc. etc. There is nothing. Just think of the problem and you can design a solution. So domain agents, we have examples like legal agent, we have finance agent, we have medical agent, we have the academic agent, or we have security agent, offensive security agent, defensive security agent, we have robotic agent designed specially for robots, and so on and so forth. So there are many agentic applications. Just think of the domain, think of problem, design a solution, and then you can build the agent that will implement it. Reference architecture for an autonomous agent app. So a practical blueprint for enterprise ready agent system. So it looks like this. This is just an example. So first of all, you have your LLM as your brain, whether it is your OpenAI API, whether it is Claude or Aiku, Sonnet or Opus or Gemini, or one of the open source or Llama Index or Llama, and so on and so forth. So you have your LLM ready, because LLM are the brain of this agent. LLM model layer, reasoning plus structured output. We have memory plus RAG, vector database, and doc history. So memory and RAG database assist the agent in making correct and accurate decision, because when they have memory, they will be able to fall back into the memory, to generate information that will access their output, and give it a accurate form of response to any question that you ask. So you start from user and app experience to API gateway, identity plus policies. So you have your user and your application, then you have your API gateway, identity and policies, very very important, security layer, very very important. Then you have your agent orchestrator, then which is where you have an agent orchestrator is just like an agent that will coordinate all the agents around it and pass information and what to do to them. Then we have two registry, API action plus API plus action. So you have the two registry of the agent, which is where the agent pick any tool that it wants to use to solve a particular problem, and all these tools have a name, they have a description and they also have a function. Then we have enterprise system. So you start from your user and app experience, very very important, agentic UI design. You have your API gateway, which is where you configure your authentication and authorization and your security policy. You have the agentic orchestrator, which is just like a coordinator that will coordinate all the agent. And then you have a registry of tools, where you put all the tools that the agent will use to solve all problems. So when you think of the problem, you have to think of a tool, a design that will solve the problem, and then you implement it into a Python function, and then the agent can call it. When you register the tool, the agent can call and implement the tool, and then they are all integrate into enterprise system. So under this, we have the undercurrent of this, which is DevOps. So DevOps is a culture. It is not just or part of software engineering where which is domain specific. No, it is everybody's business. So observability, traces, eval, cost, and quality, very very important undercurrent. Guardrails for security, uh and hallucination, validation, security, and human review, very very important undercurrent as well, which are parts of the architecture. So this is just like an overview of a general agentic system architecture in the enterprise. So code, workflow, RAG, or agent. Choose the simplest approach that can reliably solve the problem. So always make sure that before when you have a problem and then you want to design the problem, you should think of a reliable way to solve the problem before you get into your development. So guidance: agents are more powerful but costlier and harder to govern. Start simple. Okay, don't just build 10 agents at once. No, you can start from one agent. Okay, start from one agent. You can even start from reflex agent, which is the simplest agent out there. Okay, start simple, then add autonomy only when the work is dynamic. So if you have a problem that a simple workflow can solve, then why do you need to build an agent? Because when you build an agent cannot work without a brain. they need a brain, which is LLM, and then you will be paying for this LLM. You will be paying for every API call that you make. So if a simple workflow can do the task, you don't need an agent. Then if you have a problem that one agent can solve, you don't need to build 2 or 3 agents. Okay, so you have to think of minimizing cost and maximizing your profits while you are still building. So predictable inputs or known step and branches. Okay, need Q&A over docs, open-ended planning. So traditional code. So if you have a predictable input, you can go for traditional code. You don't need an agent. If you have a known step and branches, that's simple workflow. Use workflow. Okay. If you need Q&A doc, if Q&A doc is what you need, then just use a simple RAG. Build a simple RAG or chatbot. No need to build an agent. Do you understand? And then if you have open-ended problem, like a complex situation, a complex problem that Q&A cannot solve, that node step or workflow cannot solve, or that traditional code cannot solve, then that becomes an agentic problem. So you use an agent. Do you understand? So only use agent when you have a complex workflow or an open-ended problem that is so complex that none of this method can solve. That is when you go for an agent. So a practical agent execution cycle. So how do we execute agent in production? How a production agent turns a request into a controlled outcome. So control point: set instruction, limit to permission, evidence requirement, validation check, and escalation rule before the agent acts. So always make sure all these things are checked. Make sure you set instructions. Make sure you set limits. Okay, if you don't set limits, you will be burning API calls anyhow. Make sure you give the agent to permission to the registry of truth that you have built. Make sure you have evidence requirements. Make sure you do validation checks and then escalation rule before the agent acts. Make sure you set rules. So very, very important when you are building agent, you need to set rules, or you need to optimize, and then you need strategy as well. Make sure you use strategy. Be strategic in your design, and mathematics is the foundation. First principle, always apply the first principle to everything you are building. So step 1, control point, plan. Have a plan. Then 2, the agent always plan before they do something. Do you understand? Like human being, before you solve a problem, you have a plan. For example, if you want to solve a differential equation problem, all differential equations have a plan. They have a steps of solving them. So agents have a plan. They always plan before they execute. Then when they plan, number 2 is retrieve context. Context is just prompt engineering is giving the agent instruction. Context is giving the agent the right instruction that is needed at that particular time, so they can retrieve context which is required for the particular problem they want to solve. So this context which is required for the problem enable them to select the right tool. Remember, we have context engineering now, which is a kind of fine-tuned way of doing prompt engineering. So prompt engineering is just like general instructions given to the agent. Context engineering is giving the agent right and particular instruction that is needed for a particular problem. So when the agent gets the context, then it selects the tool that map to the context, and then it acts, then it validates. Validation is very, very important. Make sure you set a guardrail. Very, very important for security and responsible AI and ethic. So, and then when it validates, it gives you response, and then it learn from the process. It learn what is right, what is wrong, and what it should implement next time when it is given a contest or it is given a problem to solve. So this is how the execution life cycle: plan, retrieve contest, select true, act, validate, and learn. Alright guys, so principle for good agentic system: the qualities that separate prototype from production grade AI systems. So these qualities are what separates our agentic system from the traditional AI system. Number one, agentic system are scalable, they handle groups, they can load spikes and multiple tenants, they can integrate with multiple tenants. Agentic systems are also modular components. Modular components can be swapped, extended, and refactored. So you can build agentic systems are modular, or they can be extended, and they can also be refactored. So you can rebuild them, you can reintegrate them, you can redesign. Continuous learning improve feedback, evals, and production data. So agents learn continuously, not like an LLM that you just build, or a machine learning that you build and then it's continued that operation until you retrain and do everything. No, agents learn on their own and they improve themselves from their learning, and then they can learn from their mistakes and what they did very well and take it into memory. Number four, agents are resilient. They can fail gracefully when tools, API, or models break. Okay, they can fail gracefully when tools, API, or models break. So when tools fail, when API or model break, agent can also fail gracefully and still recover back. So they are resilient. Future proof avoids locking through standard and clean interfaces. So agents are not vendor locking, they are not locking into one interface. You can integrate them into many applications. Okay, so key takeaway from this chapter: a strong conclusion that we have here are points that we have made here are: agent decide but follow scripts. So agents are autonomous. Agent plan or retrieve contents, call to, solve the problem, validate and give response and learn from what they have done. Bots are just tools, they only follow input and give you output. They follow scripts. Number two, the modern agent stack combine models, tools, memory, orchestration, guardrails, and monitoring. Three, use agent only when the problem needs dynamic planning and autonomous action. That is when you use agent. You use agent only when you have a dynamic problem and a dynamic and complex problem to solve, not when you have a simple problem that a workflow or traditional code or Q&A can solve. Okay, then the architecture simply is user, agent, tools, and value. You have your output. So our next topic will be designing agent systems that are modular, secure, measurable, and production ready. So I hope I've been able to communicate what agents are, the architecture, the design, the uses, when to use and when not to use agent. Please like and subscribe to this channel. God bless you. Bye.